In this video, we are going over the definition of chemistry, and then we're going to move on to part 1 of the concepts of chapter 2, which is titled Chemistry and Measurements. You are officially in a chemistry class. We must define what is the discipline of chemistry. Chemistry is defined as the study of the composition, structure, properties, and reactions of matter. In later chapters, we are going to understand what is matter composed of, what are the different states of matter. But for now, understand that matter is basically another term that we utilize to describe all the substances that make up the world. In chemistry, we have many disciplines, but in this course specifically, we are first going to talk about general chemistry. And in general chemistry, we are going to be focusing on understanding what are atoms, how do we illustrate them, what are they composed of, how do they behave. Then after that, we are going to focus on one particular atom and its chemistries. So when it comes to organic chemistry, we are going to focus specifically on carbon atoms. Lastly, when it comes to biochemistry, it is important to note that that prefix bio is because we are going to understand biology, which are living systems. But we are going to look at it from a chemistry perspective. So in biochemistry, we're going to utilize the concepts of general chemistry and organic chemistry, and we're going to see many of the molecules that are in biology, but in terms of their chemistry. So with this, let's get started to talk about the concepts of chapter 2. In chapter 2, we are going to initiate our discussions talking about units of measurements. A measurement is defined as a definite magnitude of quantity, capacity, or dimension adopted by convention or by law. In simple terms, that just means that is the quantification of an object or an event. Scientists use the metric system of measurements or other modifications like the SI system, which stands for the International System of Units, in order to define and give units to these measurements. Here in the right side of the slide, we have 3 different images of healthcare professionals taking measurements in their job sites. If we look at the image on the top, we see this healthcare professional specifically taking the temperature of the patient. When it comes to specifically temperature, there are different units that can be utilized. In the US, we use degrees Fahrenheit. In many countries around the world, instead of Fahrenheit, they use degree Celsius. And in the laboratory, sometimes the unit for temperature is going to be units Kelvin. That 0 that you see, or that dot in a way that you see on the left side on by the letter F, the other one that you see by the letter C, or just the letter K, those are the abbreviations for those units of measurements. Remember that this first one is Fahrenheit, the next one is Celsius, and the last one is Kelvin units. Each of them could be utilized in order to express the measurement of temperature. In this image, we can observe that the healthcare professional is also taking a measurement. Now, by your experience and by what you look in that image, define what kind of measurement is this healthcare professional doing on the patient. So you can observe that in your future jobs, you could be taking measurements of patients in your daily life. Now, we should investigate further. How do we express these measurements? And we express them in measure numbers. Now, these measure numbers are they have a specific way that need to be written. And in the bullet points that we see here, it actually denotes the different parameters that must be met in order to write the measure number that describes a measurement. So in the first bullet point, it says that you need to observe the numerical values of the marked line. So those numerical values, if we utilize the image that is below, will be these large digits, 1, 2, 3, so on and so forth, 10, 11. So this instrument goes all the way to 17. In formal terms, the observed numerical values in the marked lines are known as known digits because they're written. That's why they're known. Measurements always have an estimated value. Now, this pertains more of measurements of length with a ruler, volume with one of the instruments that we will experience in class or in lab, because there are other instruments that don't have this estimated value, but understand that many measurements actually do. This estimated value will be the numbers that are between the marks. So if we focus on the image that we have in the bottom of the slide, because our object is actually in between 10 and 11, the estimated value will be a number in between those two. That is known as the estimated digit. Estimated digits, as you can see, are the final numbers in a measure number. And like I expressed a few moments ago, this pertains more to measurements of length or sometimes volume. So we observe the image here, and I'm going to draw a line at the tip of my object so I can know what are the known digits, the estimated digits for this object. We can observe that this object, utilizing a ruler, has a known digit of 10, which is the value that we know that the measurement has. Now, we also have in this instrument the unit of measurement, which, as you can see, is centimeters. The shorthand for centimeters is cm. So I'm going to place the unit. Lastly, I need to determine what is the estimated digit. So an estimated digit, literally like the name says, it is an estimate. So you need to picture that that space between 10 and 11 has 10 little lines. And if I estimate based on those 10 little lines that I'm going to picture in my brain, this is more, the object with this measuring device is more than halfway. I'm going to estimate that this is about 0.8. So my estimated digit specifically for this is going to be 0.8 because it is the space in between 10 and 11. So with this 0.8 is my estimated digit. So understand that a measure number must include a known digit, estimated digit, and then the unit of measurement. Let's do one more practice problem in order to solidify this concept. Let's observe this object, which is a paper clip. We have two different rulers in which we are going to utilize in order to understand the length of this paper clip. I'm going to include a line at the tip of my object to actually see where does it land in these measuring instruments. These two instruments have different known digits. As you can see in the ruler on the top, my known digits are just the whole numbers. So when I express the measurement with the top ruler, then I will write 5.9 as my measured number because the 5 is my known digit, the 0.9 is my estimated digit. And you can see that this is my unit of measurement. On the other hand, if I look closely at the ruler in the bottom, the 5 is a known digit, the 0.9 is a known digit because they're markings denoting that that is in the instrument. Now, to my eyes, I see that this paper clip is right on 0.9. So my estimated digit, because I see it right at the line, is going to be a 0. And then lastly, I put the unit of measurement, which is centimeters. So understand that depending on the digits that you have in your instrument, that's how you express the different measurements. We already practiced and saw examples with measurements of length. Let's now see other measurements that we will do in the laboratory this semester. What about if we are measuring volume? We, in this class, will be measuring many substances that in liquid form. One of the interesting things is that at times matter, when it's put in measuring devices for volume, is going to create a curvature that we can see illustrated here. And this curvature is actually known as a meniscus. The curvature can be pointing down or it could be pointing up depending on the properties of matter. Now, in the image that we have on the right side, we see an image of specifically a substance or matter that when you put them here, we can see that bottom curvature. And when we are doing measurements of volume, we actually have to take into account the bottom of the curvature in order to correctly read the volume of the instrument. So, to correctly report these measurements, you need to observe where is the bottom of the curvature, adjust the height of your eyes so the bottom of that curvature is at eye level, and then you estimate the measurement. So based on the image that you see here, estimate what will be the correct volume of this type of matter in this instrument. Please assume that the units of measurement here are going to be specifically milliliters, which the shorthand is ml. To solidify this concept, practice what would be the correct measurement of the liquid in this illustration, followed by what is the correct length of this instrument, or sorry, of this object based on the instrument that you see use in order to measure it.